Let me know when you can see me.
Refreshing. Hey!
Hey, everybody. How are you doing today, all? Hello, Magsig. Please use the chat window for letting us know. Hello. Let's see. I'm going to have to use my special glasses because it's tough for me to read because I'm old now. So, Sir Flim Flam, Scratch, Roblox, and more. Hello. Well, welcome to the question and answer session that goes over practice 1 for Circuit Lab. So before we start, I'd like to ask everyone to please make sure you don't put anything on the in the chat window that would identify anyone. Make sure that you don't put in any personal information. You only ask questions, and please make sure that your usernames do not personally identify you in any way, shape, or form. I've also got your coach, Patrick Chalker, on speakerphone. Hello, Patrick.
Hi.
And so he'll be also telling me things as well.
I'm trying to figure out the chat channel. So it looks like Sanjay's figured it out. But, yeah, we'll get there.
So I see that Sanjay Shankar says WUT, which what's up? I don't know. And then Shreya Singh says hi. So hi, Shreya. Hi, Sanjay. So those would be good examples of please try to create other monikers that that you can use. So we now have 3 viewers. We're 1 minute and 53 seconds in. Can everyone see me all right? Do I need more light?
I think everyone can see you just fine.
Okay. So did everyone who logged in, were you able to do practice 1, go through that entire video and read through all of the slides for practice 1? Oh, very good.
Yes.
Shreya said yes. Very good. Well, very good. All right. Before we start, Shreya, did you have any questions? Oh, you just got the email a few hours ago. Okay. So the first practice is really an introduction, not just to Circuit Lab, but to Science Olympiad in general. Circuit Lab is a partial test, partial hands-on activity type of event. What that means is you don't have to build a device, but you are going to have hands-on activities. You are going to have tests. But the test and the hands-on activities will only cover the topics that are listed. If you're in Division B or middle school, you only have to worry about the parts that are for Division B. If you're in Division C, you have to worry about everything. Okay? One of the key things that I want to start off every practice by saying is make sure that you do whatever your coach recommends. Okay? This is just to supplement what your coach is doing. So Mr. Chalker and I have coached together for many, many years. I trust him wholeheartedly. We are both national event supervisors. We're both on national committees. So trust him. And also, he is currently in Ohio, whereas I'm an alumnus of Ohio. I was a coach until about 3 or 4 years ago. But I've also been in Maryland, Pennsylvania, and other places. So the first thing that I always recommend everybody do is to read over the rules. So you can download the rules and then print them out. And so if you look at the rules, you'll notice that the rules generally have, this is a 2-person team. You're going to be able to use a binder, okay? But then when you get to the written test, this is where all the subjects are listed, especially in the written test section D, okay? So those are all of the items that have to be covered. And then you'll notice that 10 through 14 are Division C only. For hands-on task, that is where you'll probably get the most variation. And it really is going to depend on exactly how your event supervisor runs things, okay? And so the key thing is to just try a lot of different things before your first competition. So if you're ever wondering, do I need to know how to do a kitchen battery? Yeah, you do. Because you don't know, that might be something they think is important. Do you need to know how to make a solenoid or an electromagnet? Absolutely, you do. Why? Because they may put that on there. Do you need to know how to use a breadboard? Do you need to know how to use a multimeter? All of those things could be very, very important. Okay. Now, for those of you that did have a chance to review the materials before you came in, what are your questions? How about you?
Try typing to the chat because I don't think they can hear me.
Okay. All right. So I tell you what, does everybody know how to use the chat? Does anyone not know how to use the chat? Oh, okay. How do we get the homework generator to refresh? Okay. So I'm going to take you over to my one of my computers here. Okay. And hopefully you can see it. I'm going to come over here and I'm going to click on Circuit Lab, the homework generator. I'm just going to open it up. Every time you open up a Circuit Lab homework generator, it creates new values for you. Okay. Now, if let's say you print this one out and you do really well on it, you want to do another one, and you'll notice down here at the tab, it's level 1 VIR. So whenever I say level 1 VIR, I'm talking about the tab. Okay. And you've also got a level 1 magnetism, you've got a level 2 parallel, level 3 combination circuit, etc. If I hit F9 on the keyboard, it creates all new numbers. What's even neater though is that you see, like it says, figure out what R equivalent is, okay, in this particular series in ohms, and then what is I1, I2, and I3 in amps. What's voltage of R1, voltage of R2, voltage of R3? What's the power of R1, the power of R2, the power of R3? And then what's the total power of the system? Now, what's really neat is that you'll look down here at the bottom, it calculates all your answers. So every time you print this out, it also prints out an answer key. You hit F9 again, it's a whole new set. And so my recommendation is whenever you're using the homework generator and you're doing a particular sheet, you print out a sheet, you run through it, make sure you're accurate, and then once you have it, once you're getting 100% correct, then you can worry about trying to make something go faster. And you'll notice after each practice, I'll recommend, after level 1 VIR, we'll go level 2 parallel. And it's the same sort of thing, F9, F9. If I close it and reopen it, it'll actually regenerate the numbers randomly as well, okay? So you can create as many of these as you'd like. And in fact, it's quite often a sort of a fun little thing to do when you're a little bit nervous about a type of problem to do these. Okay, so that was a good question. Are there any other questions? Can everyone hear me?
Yeah. Is that on the national site or was that in the link that you sent me for us?
Oh, this live view?
The homework generator.
The homework generator is actually on the Google site, and it should also be on the national site.
Okay, the one on the national site you might want to pull up. It's a little weird.
Okay. All right, let me pull up the national site. By the way, can everyone hear Mr. Chalker? Sir Funflam, can you hear me?
Oh, they can hear me.
Okay, good. Thank you, Shreya. I'm glad to hear that. Okay, so I'm going to go to the national website. Now, if you remember, the national website is soinc.org. And so when I go to soinc.org, here's the national website. And I go to the menu. And Mr. Chalker, where is this stuff at?
Division B events, top left.
Right.
The second tab.
And we go down to Circuit Lab.
Circuit Lab should be near the physical science and chemistry, third one.
Mm-hmm. So
and then 2019 homework generator, if I'm not mistaken.
Yes, and so I go on here and I open it up. I've actually not opened it from the national website, so this is sort of interesting.
Yeah, it just looks a little bit different because I have the Dropbox that you shared with me.
Mm-hmm.
And I have that one open up, and it's not the same.
Oh, that's because I was working on level 15 diodes, so this is Division C. You have. So if you click here. And you can go down to the tab that we were talking about, level 1 VIR. It's the same sheet.
You're right. I see.
Okay. So yes, so it will leave you on whichever tab it was on last. And the reason why it was on level 15 diodes, which you will not have to do in Division B, is because I was creating a level 15 diode set of problems. I still have to do level 16 operational amplifier, so there will be other versions of the homework generator that will be created.
Cool.
Okay, very good. All right, so has everyone done the homework that I sent out for practice 1? So we're going to go over what that homework should have been. So if you notice, I'm going to go back here to the national website. I'm going to go to practice 1, the introduction. And I'm going to open her up. Okay. Okay. And so if I go through here, it goes through the ground rules, etc. I'm sorry for the cheesy Star Wars joke.
It was wonderful.
Thank you. So, was everyone able to make a wiring diagram for a room in the house?
All right. Not getting very many responses from the kids.
No, I'm not. So, the reason why I wanted you to do that, that's actually one of the number one questions that people will do for their hands-on activity. Is that they'll give you a house or a room in a house. Like if you look at this room here, I've got a light. I've got I've got another switch that would work well for a fan. I've got outlets and I've got a switch. And what you want to see is how each one of those circuits works and how the switch turns each circuit on and off. Or in the case of outlets, a lot of times they're just always on. So that was number 1. Now drawing a circuit for a flashlight, okay? And here, I'll show you a real simple way to find a lot of different ways of doing that. Okay? So if I go here, I add in a new tab. I go to Google and I just type in circuit for a flashlight. I go here to images, and now you see all the different diagrams. You've got ones from YouTube, you've got ones from torch switch wiring, you've got the complexities of an LED flashlight, you've got one here that shows another one, you've got one here that shows how the batteries actually fit inside the case with the spring to form the switch, and then how that switch would be drawn as a switch diagram. I'm a big believer in always start out by doing a quick Google search or a quick Wikipedia search. It's not where you end at, it's where you start. Let's go to the next homework. So if I look at the next homework, it talks about the homework generator. Okay. And it talks about how I want you to do level 1 VIR, voltage equals IR. Real quick, V equals IR is also known as what?
The big, I should say it.
So somebody type it in first.
Let's see if they say something.
Ohm's law. Very good. Very good. Very good. Okay. Mr. Ohm, yes, he's like everybody's favorite because it's the one law you should be able to look up or that you don't need to put in your binder because you just know it so well. Still not a bad idea to have it there just in case you get nervous. But V equals IR, and I is equal to V divided by R, and R is equal to I divided by, or excuse me, is equal to V divided by I. See, that's why you might want to write it down. The thing is that it's really, really important to know those, okay? So I want you to do level 1 VIR. So you'll notice I'm going to hit F9 on my sheet. Bam. Okay. So my battery is 840 volts. R1 is equal to 30 ohms. R2 is equal to 100 ohms. R3 is equal to 80 ohms. Okay. Well, easily I can look at that and say that 30 plus 100 plus 80 is equal to 210. And since they're in series, those to find the R equivalent, I just add them together. So that's 210 ohms would be my R equivalent. Now, I1, I2, I3 are always going to be the same in a series circuits because as the electrons and the holes go around this circuit, they have to be, you have the same current here as you would here as you would here. Okay? So what that means is that the same current that comes from the battery is the same current that goes through R1, R2, R3. So I1 equal I2 equal I3 equal the voltage of the battery divided by the 210 R equivalent ohms. Okay? So if I take 840, and let's just do the math here. So if I take 840 divided by 210, according to this, it should be 4 amps. Okay? So each of these should be 4 amps. Now, to figure out the individual voltage in each of these, V equals IR. So 4 times 30 would be 120 volts. 4 times 100 would be 400 volts for VR2. And for 80, it'd be 320 volts. Okay?
I have a quick question, Russ.
All right, we have a question.
Go back to the picture.
Yes.
So the amperage stays the same across the entire circuit.
That's right. The amperage is the same because
the voltage changes. Now, does the voltage change in the resistor or in the length of wire after the resistor up until the next resistor? Or what sections would have voltage? So I guess what I'm saying is between R2 and R3, the voltage there, is that different than the voltage between R1 and R2?
Okay. So the question is why is the current the same? And the second one is the voltage here the same as the voltage here, the same as the voltage here, etc. So let's start with the current question. Okay. So if you see the picture here, and hopefully this is, I'm going to try to make this a little bit, is that easier to read?
That's actually much better. Yeah, a lot better.
Okay. So if I look at that, so the deal is that every hole or positive particle that comes out of the positive terminal and every electron or negative charge particle that comes out of the negative terminal, they have to go around in a circle. Okay? Conventional current goes from out of the positive and around back to the negative. So the current is as drawn. So this is drawn for conventional current. What you'll notice here is that, so I1, if I've got, in this case, 4 amps coming into here, I've got to have 4 amps coming out, and I got to have 4 amps coming in, I got 4 amps coming out, and 4 amps going in, 4 amps coming out, and 4 amps going back in. I can't have any leakage, okay, because it's a perfect circuit. The other thing is that remember, V is equal to IR. So the voltage is equal to the current times the resistance. Now, in this particular case, this wire here is considered a perfect wire. In other words, it has no resistance and it can handle an infinite amount of current. Okay? No wire is perfect, but for our purposes, we're going to pretend like this wire is perfect. Okay? So what that means is the voltage here is the same as the voltage here, is the same as the voltage here. But from here to here, even though the current's still the same, I have a resistance. So the voltage across here is equal to that 4 amps times resistance 1, which would be 30. So it would be 120 volts. So whereas we were 840 volts here, we're 840 volts here, we're now 720 volts here. Does that make sense, everybody? By the way, can you see the cursor?
Yes, you can see the cursor. Yeah.
Okay. Now, as we keep going around here, 4 amps. So if I got 4 amps coming out here, I got 4 amps going around here, and 4 amps coming down here. So I got 4 amps going through the resistor. Okay. So 4 amps times the resistance of 100. So that's 400 volts. Okay. Now remember, we were at 720. Now when we take away 400, 720 minus 400 is 320. So we're at 320 volts here. Does that make sense? I'm seeing some yeses, so I'm feeling good.
Yeah, I think it makes sense.
So we got 320 volts here. We got 320 volts here. We got 320 volts here. Because remember, this wire is perfect. Now we got 4 amps still going through this last one. And 4 times 80 is 320 volts. So we have 320 volts here. We drop it down to 320 minus 320. It's 0 volts. And lo and behold, we're going to explain later, not now, but later, why that means we absolutely got the problem right. When you do the entire loop around there, and the voltages all equal each other, it's a way to double check your answers. So let's see if we got the current and the voltages right. So I'm going to go down here. I'm going to scroll down here. 4 amps, 120 volts, 400 volts, 320 volts. Yay. Now, what I do is I take the current times the voltage, or I take the current squared times the resistance, or the voltage squared divided by the resistance, and I can determine the power in watts. And you'll notice that it comes out to about 480 watts for the first resistor, 1600 watts for the second resistor, and 1280 watts for the third resistor. Now, you'll notice if I add those 3 numbers together, and by the way, if you select all these, and then I look over here and the sum is 3,360, so that is the power of the total. But I could also determine that by taking 4 amps times 840 volts. And 4 times 840 is 3,360. Okay? You'll also notice that in all of these cases, in this case, it was 4 amps all the way around. In this case, it was 3 amps all the way around. In this case, it was 2 amps all the way around. Okay, so in a series circuit, the current is always going to be the same, because think about it being like water. The water's got to go somewhere. You're not adding any new water. You're not losing any water. So therefore, it has to go somewhere. So very good question, Mr. Chalker. Okay. All right. What other questions do you have? Are these materials helpful? Oh, very good. Very good. So my recommendation, once you are getting through the level 1 VIR, and you're able to print out multiple copies and you're able to do all 3 sets without any problems, that's when I want you to then go to practice number 2. And what we're going to do is every week, I'm going to have a question and answer session like this, okay? Next week, the rest of the nation's actually going to be online. So we're probably going to have a lot more than 4 views, if you know what I mean, okay? And it'll be a lot of fun. The other thing I want you to do is I want you to please make sure you tell me if there are problems with the video. Tell me if there are problems with the materials. As Mr. Chalker will tell you, when I'm doing this in person, I would actually give candy to anybody who could find errors in my slides or in my questions or my keys. And I used to give out a lot of candy. Okay. Unfortunately, I won't be able to give you candy, but Mr. Chalker has assured me he'll take care of you in that department. I'm just kidding. I'm just kidding. Wait, he just said he would give you candy if you can find errors. Now, does anybody have any questions about binders?
About what?
Binders.
The binders. I think so. Circle plan, I think is great. Shreya is that, and then yeah, we need a binder.
Yes, you will need a binder. Okay, so here's the great news. Who here has ever had an open book test? A binder allows you to have an open book test, and it's even better because you write the book. Okay, so my recommendation is that you get at least 1.5 inches to a 2-inch binder, no more, especially at the beginning. And what you want to do is you want to put materials in there that are very easy for you to look up and find. And what you're going to find out is that after each practice and as you learn more, you're going to put more in that binder. Okay? When in doubt, if you've got like 2 biographies of Michael Faraday, okay? And by the way, you're not going to want to have more than a few paragraphs and bullet points on each scientist. But if you've got 2 of them, you include both. Why? Because you never know which fact the event supervisor is going to ask you for. If you have 2 drawings of how house circuits work, include both. But remember, it's not just that you're trying to capture exactly what the question they're going to ask you on the test is. What you're trying to do is you're trying to create your own study guide. Okay? So one of my recommendations is to always, always, always make sure that your binder, you can find anything within 10 seconds. And in fact, we're going to do a binder check at the beginning of next practice. And I'm going to ask you questions like, what's the conductivity of gold? That's going to be one of the ones I'm going to ask. I'm also going to ask you what the conductivity of glass is. I'm also going to ask you to quickly find your rules. Because you remember I showed you the picture of the rules? That needs to be like your first page. And you need to know them very well. Okay? Then I'm going to ask you, show me the equation for Ohm's law. Show me the equation for power. You should be able to find these very, very rapidly. Okay? As we go on, you will notice that the homework in almost all the sections, especially later on, is work on your binder. Your binder is a work in progress. And in fact, if you use it right, it's going to look very dog-eared and very worn by the time you get to your first competition. In fact, with some things like the rules and some of your key things like your list of materials, okay, I would put those in a protective sheet so that they don't get worked. We've got a question here. For the questions, they're all in the practice videos. But more importantly, download the PowerPoint file itself and use the PowerPoint file. Okay? And remember, those questions are just your start. Work with Mr. Chalker and your other coaches to come up with other questions. Also, Mr. Chalker's got my email. He's more than happy to reach out to me, and my email is actually in the presentation as well. And the PowerPoint files are also on the national website. So go through them and then ask questions. The other thing is, I gave a whole bunch of other links. YouTube has got a ton of great videos that are even better than mine. They've got better graphics and such. Mine were specifically designed for coaching Circuit Lab. Okay. Any other questions?
I think that we will. I'll have more for you next week, or I'll communicate with you after tomorrow's practice.
Sounds good. And so, best of luck to you. Go Maggots this year. The number one thing that I will tell you, the people who prepare the most do the best. The people that work best with their partners do the best. The people that put in the work will see benefits. Okay? I can't promise that you'll be in the top 2. Magsig's a real tough team to be in the top 2 in any event. But make sure you work as hard as you can, and you're going to have a great season. I know you will. Mrs. Chalker is the one who taught me everything I know about Science Olympiad. All right. Are there any other follow-ups? How about for you, Mr. Chalker?
No, I think this is wonderful. I'm excited. So.
Okay, I'm gonna try something here real quick, and tell me if this light makes it better or worse.
Okay.
Does that light work better or worse?
It's better for seeing you. Can you rotate the camera to the computer monitor?
1 second. Here we go.
With the light on. Turn the light off. It's probably better off.
Okay.
Computer monitor. With you, it's better. So take that. Yeah.
So what I'm gonna do is I'm gonna do that and flip it over. There you go. All right. Well, hey, you were the test subjects for this. Are there any other questions? All right. So just remember.
Messages, but that's okay.
Yeah. So, and if you have any questions, feel free to email Mr. Chalker, reach out to him. The other thing I would say is that in your binder, if you ever have a doubt as to whether you want something in your binder, put it in. Make sure it's well tabbed so you can find stuff. Because like I said, we're going to do a binder check at the beginning of each of these Q&A answer tests. And I expect everybody to be able to find stuff within 10 seconds.
Okay.
All right. Well, with that, thank you all, and go Maggots. Take care, everybody.